Hi everyone, I'm going to briefly talk about the environmental benefits of remanufacturing and some exciting results from a recently published report. My name is Brian Hilton and I am a senior engineer at the Golisano Institute for Sustainability at the Rochester Institute of Technology. I personally have been focused on sustainable product design and remanufacturing for over 25 years. As you are aware, we live in a resource-constrained world. Currently, there are over 7.5 billion people competing for Earth's limited supply of fossil fuels, water, and material resources. In just my lifetime, which I've projected onto this graphic, the Earth's population has more than doubled. This is therefore not our grandparents' world. We need to support a larger population and encourage a better standard of living. However, we cannot treat our resources as if they are endless. We are currently seeing extreme damage to the ecological system, such as vast expanses of lost forests and high levels of pollution and depleted natural resources, such as potable water, minerals, and fossil fuels. This data shows that there is an urgent need to adopt more sustainable practices. One such practice is to engage in a closed-loop economic system as prescribed by the circular economy. The circular economy is an industrial system that is restorative or regenerative by design. It keeps our natural resources in use as long as possible and recovers materials through recycling and regenerates products through remanufacturing at the end of each service life. Every product has a life cycle, starting with the extraction of raw materials through the final disposition at its end of life. Each activity in a product's life results in the environmental or human health impacts due to consumption of resources, releases of emissions, or other exchanges. These inputs and outputs can have a negative impact on the world around us, but can be minimized when materials and products are circulated back into the system. Remanufacturing can be a major part of this solution. In one of the first studies of its kind, the International Resource Panel Working Group on Circular Economy prepared a report to better understand how to decouple economic growth from environmental degradation. Though this report considers all value retention processes, today I am focused specifically on providing a high-level overview of remanufacturing and the potential opportunities. The case study examines specific environmental and economic impacts of 9 case study products across 3 sectors and 4 sample economies of Brazil, China, Germany, and the US. It looked at the costs and impacts to make new case study products as well as to perform each of the value retention processes. In general, we looked at the difference between brand new and remanufactured case study products using material use and waste generated during production, the energy and carbon emissions embodied in the material, and manufacturing processes, as well as the costs associated with building new and using value retention processes. I highlight the cost not only because production has to be financially viable, but to me, calculating the environmental impacts of a product is similar to performing the total cost of ownership analysis. All of the inputs and outputs from raw material acquisition through end-of-life disposition are totaled. Calculating the impacts of remanufacturing can also be challenging because there are different business reasons to remanufacture, resulting in defining different product life cycles. Remanufacturing has been around since the 1930s and has been used to recapture the yield fallout waste and end of production line waste and warranty returns and extend the life of leased products, provide replacement parts, and lower the cost basis of the new build by integrating remanufacturing directly into the new build line. However, once the system boundaries are defined, modeling the environmental impacts of remanufacturing, though not trivial from an engineering perspective, is no different than modeling the impacts of any other manufacturing process. The study system boundaries were set up to directly compare the separate life cycles for the new and remanufactured case study products. In many cases, these were manufactured and remanufactured by the same OEM, and we are very fortunate to have direct access to the critical life cycle data, such as bill of materials and manufacturing and remanufacturing process details. Results of the study show what remanufacturers already know, that remanufacturing can produce amazing results. The remanufactured case study products had between 79 and 99% lower greenhouse gas emissions than their new product counterparts. Similarly, remanufacturing reduced the requirement for new materials by between 80 and 98%. These are exciting results that companies need to leverage. Integrating the results of a remanufactured product with its new build product line can enable companies to reduce the environmental footprint of their products and their operations beyond what is typically achieved through incremental improvements. So if we tie these results back to the beginning of the presentation, an important conclusion is that remanufacturing can be used to allow us to be better stewards of our natural resources and to actually decouple resource use and environmental impact from economic activity and human development. But just because remanufacturing will lower environmental impact and lower costs does not mean it will automatically be adopted. To realize the decoupling benefit, we need to work together to break down existing barriers. The IRP report identified a number of barriers that industry leaders such as the Remanufacturing Industries Council are working to remove. Barriers such as regulatory barriers that label end-of-life products as cores, as used, waste, and therefore restrict the trade and free flow. Market barriers limit the customer awareness of environmentally friendly options, collection barriers that increase the cost and complexity of reverse logistics systems, and technological barriers that limit the flow of enabling design and process knowledge. This hard work, however, has huge potential and is worth doing. Although current adoption remains low, with remanufacturing accounting for about 2% of the production in the US and in Europe, it is estimated that as much as 41% of the aggregated manufacturing GDP for the IRP study economies are potentially appropriate for remanufacturing and other value recovery processes. This suggests that there's extensive opportunity for growth. Overcoming barriers will also open new markets while generating environmental and social value. I know in this short time frame I was only able to scratch the surface, and hope you are inspired to go read the final report. I would like to thank Dr. Nasser and Dr. Russell for providing some of the content. Please send any questions to the email provided, and I hope to see you at the next RIT World Remanufacturing Conference in October, where the environmental benefits of reman will be taught as a short course on October 8th. Thank you.